video will cover the domain of a function. You might recall from previous videos that the domain of a function is just the set of x values. If x is in the domain of a function, then f is said to be defined at x. Think about the opposite of the word defined is the word undefined. So we are looking for values for which the function is defined. The implied domain of a function is a set of all real numbers for which the expression is defined. The reason we have implied domain is sometimes the domain of a function is actually expressed. But right now we're talking about functions whose domain is not expressed, and we have to figure out what the domain is. So take a function like f of x equals 3x plus 1 and ask yourself, are there any numbers for which this function is undefined? In other words, if I do the little t-chart over here, are there any numbers I can't use for x? No matter what number I put in for x, I get a defined value. I can use whole numbers, I can use negatives, I can use fractions, I can use decimals, and no matter what number I use for x, I'm going to get a defined value at y. Where we don't get a defined value of y is these two situations. If you've got a function where you might get a 0 in the denominator, or you might have to take the square root of a negative, then you're going to have to put on some domain restrictions. But mostly, we're going to have a domain that is all real numbers. So to name all real numbers, we're going to name it with interval notation. All real numbers would be from negative infinity to infinity. When in doubt, go with the all real numbers. The two cases you have to be careful of is fractional expressions where you would get 0 in the denominator, or if you would end up having to take the square root of a negative. So let's take a look at some examples. So let's take a look at a couple of these that are fractional expressions and just look at the denominator and say, are there any values of x that would create a 0 in the denominator? And the way to find that out is to actually take the denominator, set it equal to 0, and solve. We don't want it to be equal to 0, so let's set it equal to 0 and find out what values would make that happen. To solve this equation, we're going to have to factor this. It's the difference of two squares. It factors as x plus 2, x minus 2, and then you can use your zero products property and set each one equal to 0 and get negative 2, and 2 are your values that would give you a 0 in the denominator. These are the values that need to be thrown out. We are excluding negative 2 and 2 from our set. One way to do this is in set builder notation and say all x such that x does not equal negative 2 or 2. Or we have to use our interval notation and write several mini intervals. Our interval would be from negative infinity to negative 2. With a curved parenthesis because we don't want negative 2 itself, union with negative 2 to positive 2, curved parentheses for both, union with 2 to infinity. Sometimes they're a little bit easier to do. This denominator, there's not much to it. If I set that equal to 0, x plus 7 equals 0, just subtract 7 from both sides and I get x equals negative 7. Set builder notation, it is all x such that x does not equal negative 7. Interval notation would be from negative infinity to negative 7 with the curved parenthesis, union negative 7 to infinity. Let's take a look at a couple with square root. The difference on the square root is we can't take the square root of a negative. So we have to ensure that our radicand, that's the stuff that's under the square root, is greater than or equal to 0. So solve this equation, add 4 to both sides. You have 3x is greater than or equal to 4. Divide both sides by 3. And we have x greater than or equal to 4/3. That is our domain. This is not what we are excluding. Our domain is valid for any value greater than or equal to 4/3. So in set builder notation, it's all x such that x is greater than or equal to 4/3. In terms of our interval, x greater than or equal to 4/3, that will be the closed bracket starting at 4/3 and going on up to infinity with the curved parenthesis. Just like the last one, take what's inside the square root and ensure that it's greater than or equal to 0. Solve this, subtract 7 from both sides, and then divide by 2. gives us x greater than or equal to -7/2. Set builder notation, all x, such that x is greater than or equal to -7/2. Your interval notation is just like this one over here, square bracket, -7/2. You could write it as -3.5 or -3.5, all the way up to infinity. Got to be careful, it's not just the square root that can result in a restricted domain, it's any even root. So it doesn't matter what this is, as long as it's an even number, I know I got to be sure that what's inside the radical is greater than or equal to 0. So set this greater than or equal to 0 and solve very simply. Add 6 to both sides. My set builder notation, I can use it right here, just put our x such that x is greater than or equal to 6. Interval notation starting at 6, going to infinity. This is a cube root. You can take the cube root of a negative, which means there is no problem with a negative value for x. There is no number that we need to exclude from our domain. So our domain on an odd root is going to be all real numbers, which is -infinity to infinity. How about 2x squared minus 7? Is there any value that we need to exclude? Well, think about our two cases. Is this a fraction? Nope. Is this a square root? Nope. Which means any number can go in for x, so that our domain is from -infinity to infinity because it is all real numbers. Now this one over here, we've got to look at two things. Because this is a square root, I've got to be sure that my x minus 3 is greater than or equal to 0. Add 3 to both sides. It is x greater than or equal to 3. But wait, here's a little problem. If I solve this one, I am looking at x minus 4 equal to 0, and I get x equal to 4. Really, I'm saying x cannot equal 4, because if we use 4, we're going to create a 0 in the denominator. So that this is actually all x, such that x is greater than or equal to 3, and x cannot be equal to 4. Now, as far as our interval notation, we're looking at 3 up to 4 with a curved parenthesis, because that means 4 itself can't be included, union with 4 with a curved parenthesis up to infinity.